Today we're looking at notes K-2. We are refreshing log properties expand from Algebra 2. So recall that the product property of logs is as follows. Log of A times B is equal to log of A plus log of B. The quotient property states that log of A divided by B is equal to log A minus log B. The power property states that log of A to the power of B equals B times the log of A. We also want to refresh some of your rational exponent rules. So remember that the square root of x, it is implied that there is an index of 2 here and there is a power of 1 here. And so this can be rewritten as x to the 1/2 power. Remember that the numerator goes inside, the denominator becomes the index. In which case the cube root of x squared would be the same thing as x to the 2/3 power. Okay, if you have something like the square root of x to the 5th divided by y squared, where both of these are inside the radical, okay, again, remember there's an implied index of 2 here, so this would become x to the 5/2 divided by y to the 2/2, which would eventually simplify or clean up to x to the 5/2 over y to the 1st, because 2/2 is 1. Okay, so also let's recall that log base 7 of 1 means, if you're converting, 7 to what power equals 1? Well, 7 to the 0 power equals 1. Remember again from our graph that you can remember that the coordinate 1, 0 is on every log no matter what the base. Okay, log base 7 of 0, again, think about the graph. You cannot have an x value of 0 because log of any base has an asymptote on the y-axis where the x value equals 0. So log base 7 of 0 would be undefined. It doesn't matter what the base is here. We just chose a random base. No matter what the base is here, if you have 0 here, that's going to be undefined. Similarly, no matter what the base is here, if you have a negative 7, a negative x value, again, recall where the asymptote is. Okay, because of that asymptote, you cannot use any x values that are 0 or negative. So again, this is undefined. Okay, again, for both of these, you should think about the asymptote and the graph. Okay, and then lastly, log base 7 of 7, this again, if you're converting to an exponent, means 7 to what power equals 7? And that's going to be 1. All right, so now let's get to the expanding. So if I ask you to expand log base 10 of 5x, okay, you're going to rewrite using the same base. And I'm just not going to write it because base of 10 is implied even if you don't write it. So log of 5 plus log of x. That's using that product property. When you have two either variables, a variable and a number, two things being multiplied by each other, you can split them up with the plus sign in between. Okay, now here I will use my product, my power, and my quotient property. I'm going to give each the a, the b, and the c their own log base 6. So this would expand to log base 6 of a plus that exponent of 3 only goes to the b and it goes out in front using the power rule. Okay, 3 log base 6 of b, and then minus, because the c is in the denominator, log base 6 of c. Okay, these are my final answers on these. All right, so let's look at this. Although it looks funny, you're going to use your power property. So this would come out in front and it would equal, I forgot my equal sign here, -2 was the power, log base 4 of x. Okay, on this one, you first want to convert that radical into a rational exponent like we did above. So this would be ln of x to the 1/3 over y to the 1/3. Okay, and then you're going to use your quotient and your power property. So you would have 1/3 ln of x, remember bring the powers in front, minus 1/3 ln of y, minus because the y is in the denominator. All right, so here on this one, when you have ln of x plus 1 over x to the 3rd, you have to remember that this is, even if it's not written in parentheses, you have to imagine parentheses around. Our property up here is a product property, not an addition property. So within the log, two variables or numbers, something like that, has to be multiplied by each other, not added in here. You cannot split that x plus 1 up. It will stay together. So this will just look like ln of x plus 1, parentheses around it now because now you don't want to confuse the fact that these are joined together, minus 3 ln of x. All right, so that's it on that one. On this one, it's kind of similar to where you have to imagine this x squared plus 6 joined together, but first we're going to convert to, oh, not ln this time, log. We're going to convert to a rational exponent instead of a radical. So log base 10 of x squared plus 6 raised to the 1/2 power over x to the 4th, because the only thing in the radical is the numerator, not the denominator. That didn't get affected. So then now you will say 1/2 log x squared plus 6, cannot break that up, stays together inside, minus 4 log x. Brought that power of 4 in front. That's it for your expanding. Okay, now we're going to talk about one more thing. We are going to talk about writing your answers in terms of ln2 and ln3. So what you're going to do for ln6 is you're going to think of natural log of 6 as natural log of 2 times 3, because 2 times 3 is 6. So then you can use your product property, and you can say ln of 2 plus ln of 3. All right, look at ln of 12. In a similar fashion, you can say 12 is 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. So then you can split this up, again, using your product property, ln of 2. And on this one, actually, since you have 2 of the same, we're going to first do this, 2 squared times 3, since you have 2 of the same numbers. And then you can simplify even more by saying 2 ln 2 plus ln 3. All right, look at ln of 36. So natural log of 36 can be rewritten as natural log of 6 times 6, right? 6 times 6 is 36. And then you could even say natural log of 2 times 3 times 2 times 3. All right, because 2 times 3 is 6, and then the other 2 times 3 is 6. And then you can kind of do like what we did above, and you can say natural log of 2 squared times 3 squared. You have 2 2's and 2 3's. And then final answer would be 2 ln of 2 plus 2 ln 3. All right, let's look at natural log of 9 divided by 4. So again, you want to get in terms of 2 and 3. So you can rethink of natural log of 9/4 as 3 squared over 2 squared. So then you could say 2 ln 3 minus 2 ln 2. All right, last one here. Natural log of square root of 12. So on this one, this is the same as natural log of, let's write it 2 times 2 times 3. Okay, 2 times 2 is 4, times 3 is 12. And within the square root, you have a pair, 2 times 2. So you could rethink this as natural log of 2 square root of 3. And then again, you don't want to keep the square root, so you would think of this as natural log of 2 times 3 to the 1/2. And then final answer would be ln of 2 plus 1/2 ln of 3. That's it for those.